I've got a joke for you. One of my friends asked me how hard it must have been to build the pyramids. I said, well, it's from the ground up. Today, we're going to be learning all about pyramids and prisms and how we can identify them from their characteristics. All right, good luck with your sums. Okay, we're going to be investigating some prisms and pyramids. And what you can see up the top here is I've got some examples of some prisms and pyramids. So over here, I've got a cube or a cuboid, as it's like to be called. It's a four-sided shape, but this is the 3D version of that shape. So it's a square, you can tell by those. Now, this is actually a prism. It has a thing called a spine. We call this a spine through here, and it's an edge. But to do the difference, we say there's a spine there, or there's a spine through there. And this ends in an apex or a point. So out of these four shapes, this one ends in a point and this one ends in a point. Now when it ends in a point, when all those angles there end in a point like that, we call those pyramids. So these two are prisms, these ones are pyramids, okay? So some 3D shapes are polyhedrons. This means that each surface is a polygon. So the polygons we most commonly come across are pyramids and prisms. Prisms have identical parallel faces. So what it means is this face is generally the same as the face that sits underneath it. So this face here is the same as the bottom face. So the top of it is the same as the bottom, okay? That's what we see when we see those. And we name our shapes from their base. So down here, we have a square, and that we know that's a pyramid. So that's actually a square-based pyramid or square pyramid. I like to say square-based pyramid because then that reminds me that I need to name it after its base, okay? And over here, you have a five-sided shape just down here. 1, 2, 3, 4, and 5. Okay, so that tells me it's a pentagon or pentagonal pyramid. So a pentagon has 5 sides. So this is a pentagonal pyramid. Now, a couple of things that we want you guys to be able to investigate when it comes to these things is faces, edges, and vertices. So faces are anything that sit on the top. So I'm going to use the cube as an example. We've seen that a lot. We see that on a dice, and we know that a dice has 6 faces. Okay, so it has 6 faces. Okay, how many edges has it got? Well, these are edges here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There are 12 edges. So the top part, an edge, you can fall off the side. Vertices are where 2 lines intersect, okay? And what that means is, see how we got lines that meet up here? There's 1, 2, 3, 4, 5, 6, 7, 8. And we have 8 through there, okay? Let's have a quick look of the same with C. We've got 1 face, 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 face through there, so there's 4 sides, and then there's 1 on the bottom. So there are 5 faces to that shape. Edges, there are 1, 2, 3, 4, 5, 6, 7, 8 through there. And then how many vertices have we got? We have 1, 2, 3, 4, and 5. And I like to draw just as I do when I'm doing my work, and I always have. Sometimes it can get confusing, and you would have noticed that when I was doing the edges. Sometimes it can get confusing of which ones you've counted, because sometimes you might accidentally count them twice, so you've got to be very, very careful. And here we've got another one, and you might like to have a work through these. How many faces, vertices, and edges have each one of these got? There is a formula that you can use down through there, made by Leonard Euler. He was a mathematician. He came up with faces plus vertices minus edges. And look, we don't do that too much as far as in grade 6, but it's there just in case. But all I want you to do now is I want you to go through and I want you to name all the faces, the vertices, and the edges of those shapes. Okay, and what you've got here, we've just done all those working out for you. So we should be able to illustrate understanding of prisms and pyramids by their characteristics, how many faces they've got, how many vertices, and how many edges they've got. Here's a quick look at being able to identify these shapes, or these 3D shapes, from their nets. So these are when the shape has been unfolded on a piece of paper. So if I take the first one, for instance, this one here, if I was to fold that into its 3D shape, that would give me a cube. And I think most of us by now would have made that shape, okay? Now, can you tell me what the rest of these shapes are? Straight away, I've got a rectangle down the bottom, and I've got triangles on the base. That, my friends, is a triangular prism. Now let's see if you can get the rest of those right. Pause the video now and see if you can find out what they are. And we can see here, so hopefully you got some of those right. I've actually highlighted their base shape, where they get their name for their prism or their pyramid on the screen. Hopefully you went well. If not, rewatch the video. Maybe there's some tiny little thing you may have missed. Okay. All right. Let's go to the next one. So the final thing I want you guys to learn when it comes to your 3D prisms and pyramids is their cross sections and being able to identify what their cross section is. So a right prism is a 3D object with two congruent or matching ends. Okay, so remember our prisms have got those two matching ends. Now if I was to chop them in the middle, those ends would be on each side. And what I mean by that is, see where you've got the prism here, I've chopped this one in half, as you can see through here. Okay, so that's been chopped in through there. And what that means is this is what that cross section looks like. Now, the cross section of this shape is a rectangle. Let's say I was to get a knife and I was to cut through my Toblerone like this, okay? That would give me a cross section of here. Now you'll hear the word congruent angles, and what that means is that this is, or congruent shapes, this shape is matching this shape. So you may hear a teacher say to you, yes, they've got congruent shapes. That means that they've got the same shape on both sides. So when I cut through this part here, I use my knife, and I cut through, I'll use a little sword. I'll cut through there, that'll give me, if I was to open that shape up like this, it would give me this. This is the cross section that I would see. It's another way that we can identify our prisms via their cross sections. So that's just giving you a bit more of understanding with that one. Obviously, when I do the same through with the pyramid, and I chop through the pyramid, the cross section is the same as its base. Okay, so I chop through that. That means that the cross section is the same as its base. So if it's a square pyramid, cross section is still going to be that square. Okay, all right. Hope that made sense. So the final part of this video is to look at our understanding and to see where we are using that Mazzano self-assessment scale. So we're one of the 4 areas down below. I'm going to go through those with you very quickly now. So beginning is that we really don't understand the task. We're still unsure, and we may need to re-watch that video again. And the next stage is our developing. So we've learnt it, we understand it, parts of it, but there are still questions that need to go. We've still got questions before we get to that better understanding. So the next one is our competent. This means that we understand it quite well. We can work independently, but there is still, and we can problem solve by ourselves. But there may not be some areas that we're still struggling with. And finally, we're at that proficient stage. This means that we understand it very, very well. We're getting most of our questions correct. And we could actually hold our own masterclass that we could actually teach other people how to do this concept as well. Okay, very important that we look at our Mazzano self-assessment. Whereabouts are we in relation to our understanding?